Okay, this is a slightly shorter tutorial just to cover the idea of how you use analog in your games. We've already talked about the game controller before. Essentially anything that we use here in terms of the thumbsticks and the triggers are analog values. Now on an Xbox controller, and very much it's similar in pretty much any controller that you buy today, the value that you get is a value of between 1 positive when you move right to -1 when you move to the left, and it's inverted on the vertical. So this means that you have to take into account that when you push up on an analog controller, on the game controller, it actually moves physically on the screen something downwards unless you do something to invert that, which is really simple. It's only a matter of a minus sign in your code. But developing that only takes 2 lines of code. We can start off just by responding to our left thumb controller, which seems to be the easiest one for most games play anyway. So again, because our abstract sprite has this direction vector 2 in there already, we can go through the process of updating that direction based on the values from the thumbstick. In the previous example, it was suggested that you needed to set direction to 0. That only applies with the D-pad. When you're using this one, you'll be assigning values every time to X and Y, so it will be sorted without having 0 in it. Okay, so again, there's not even need for an if statement in this case. We just need to set the direction correctly. So if we look at the X direction first, so we can set that value based on the thumbstick. Now I'll demonstrate this once we've got the Y in as well, but you'll see how everything works. So again, it's back to gamepad, get state, player index 1, now instead of going for the D-pad, we're going for thumbsticks. Okay, and we're going to go for the left thumbstick. Okay. Now at that point we can read a value from that thumbstick. So as already said, it's going to vary between -1 and +1. So that's going to give us quite a slow movement on the screen, but we'll look at how we can improve that in a minute. So that in its own right will deal with completing the X direction. If you push left, it will go left. If you push right, it will go right. We can repeat that code with a minor modification, obviously, for the Y. So it's really quite simple. When I first started learning to do games programming, I thought this was going to be the hardest thing in the world, and actually it's the easiest thing in the world. It's actually easier than using a D-pad. So at the moment, the only problem we have is because the Y is inverted, so pressing up makes you move down and pressing down makes you move up. The next thing you have to do is just invert the Y. So all you do is in front of your retrieved value, you put a minus sign, and that will automatically invert whatever comes in. So a negative will become a positive and a positive will become a negative. Nothing like a little bit of maths in the course, is there? Right, so when we run that, again, it's not very exciting, I know, but we've now got an animated sprite in the top left hand corner, and when we move, you'll see that it moves based on the thumbstick. Now it's a little bit hard to show, but you should be able to see there's a variation of speed based on me moving that thumbstick. So a small amount of movement in the X on the thumbstick gives a slow movement on our saucer. Big movement makes it move faster, so there's that analog nature to it. The other thing you'll probably notice is the fact that we now have locations in X and Y which are floating point numbers. So instead of it being at 76 pixels on the screen in the X, it's actually 76.126121. Okay, and the same with the Y. And that's because if you want smooth animation in your game, you're generally going to have to deal with something other than integers. So these coordinates are actually floats. Now we've already said that this particular example is moving quite slowly, and generally gameplay at that speed is not very helpful. So what we can do is we can put a little bit of an acceleration factor on there. So at the moment, its maximum speed we're going to get is 1 pixel every 50th of a second. So that means that in a second we could move 50 pixels in total. We can up that a little bit, we can make it a little bit more interesting. I've found that somewhere in the region of about 5, now I'm putting an F after the 5 to indicate that it's a floating point number, and that is important because it won't compile without it, okay, and your maths won't work either if you did manage to get it to compile. So at that point, what we've now done is we're now multiplying that by a factor of 5. So the maximum speed we can get is 5 pixels every 1/50th of a second. Okay, if you want to multiply that out, it's about 200 pixels every second if you maximum push on your thumbstick. And in this day and age of high resolution screens, that's quite an acceptable value for movement. So if we now multiply that out yourself if you want to do a little bit more, but now you'll find that you now have a little bit more functionality. Things are moving a lot faster. This sort of starts to correspond to the idea of gameplay now. You're sort of able to deal with that quite well. It seems quite playable. Okay, so very simple, and it gives you that ability to be a little bit clever about what you do. If you want to be really clever, you could possibly improve this slightly by adding in maybe some acceleration from the thumbsticks. So you could add further calculation on the end